Hey everybody, I'm Matt Lehman, and you're at Python Frederick. And today we're going to talk about web frameworks and do a comparison between, amongst a few popular options in the ecosystem. I know a thing or two about web frameworks. I'm a developer at Storybird. I'm the lead developer, and we're a big Django shop. So hopefully I'll share some knowledge that you guys can take away and do something about. So our key question for today is what is the right framework for my next web project? And before we can even look at the options, I think there are some questions that we really need to consider, to ponder. These are things that you should think about before you start, knowing what kind of project you're even building. Hopefully you have a project in mind. Maybe you're just playing. But if you do have a project in mind, some things that you have to think about is, are you doing server-rendered HTML? Is your plan to make templates that are on a server and put them all together and display them to the user at the other side? That's one option, and one very popular option. Another popular path to go down is to build an application programming interface, an API, and use it to power some kind of JavaScript client that's on the browser that sits on the other side. I've listed the very popular ones here: React, Angular, Ember Vue, etc. There are others, so if I'm being a zealot against your JavaScript framework of choice, sorry. And then finally, something you have to think about in terms of yourself is your development style. Do you like putting a bunch of components together and starting with something very minimalist and building up the thing that you want to make? Or do you not care about that stuff and you'd rather have some kind of solution that puts those pieces together for you, with the trade-off of maybe it's not the way you would have done it? I think those are the things that you need to consider when you're thinking about what you're going to build. So here's what we're going to look at today: 5 different frameworks, some popular, some new, but just a fun mix of frameworks that I think either are huge players in the ecosystem or are going places. There are tons of Python frameworks, just like in every language, I'm sure. PHP, I know, has tons of them, and just about every language I observed everybody seems to be able to make web frameworks. That's like the thing to do. So our time is limited. We're going to look at 5. If you're looking for others that are some good choices, like Bottle, which is a very small framework, or something that's more asynchronous, like Twisted and Klein, or AIO HTTP. Those are other good choices, but these are the choices that we're going to explore here today. I do need to present my bias, and it is obvious because of where I work, but I work on Django every day, and it influences my views in ways that you will see. I'll try not to be too blatant about it, or I'll be at least honest about where I think something is maybe better than the other. But yeah. Sorry, not sorry. So when we're thinking about frameworks, we have to think about frameworks on a spectrum. Each thing has its own set of features, and mostly these are design choices that framework authors have made. There's a lot of smart people putting frameworks together. If one framework seems really small and seems like it's missing things, it may not actually be missing, it may be purposefully left out. And that's a common thing that we'll see in a couple of these. Or you might see something on the flip side that seems like, wow, they just included the kitchen sink in this. So what's the deal with that? So I took the 5 frameworks that we're looking at, and I thought about, where do they fall in that we're going to do very little for you, or we're going to do a lot for you? And so this is going to be the order, and this will be actually the order that we review a lot of these frameworks, because it's kind of easier to build up over time to see, here's the common thing that they all do, and then add on to that. So Falcon has a very small feature set. It's designed with a particular purpose about APIs, building application programming interfaces, and it's really optimized for that goal. Based on everything that I can observe in their documentation and see about the project. API Star, as you might guess, is also in a similar vein. This is a new framework, so I think there's a sense of it growing more, but it's less than a year old. So today, if you were to pick up API Star and try and use it in some sort of production setting, there's not a whole lot it can do for you out of the box, especially when it comes to integrations with third-party things and that kind of stuff. Moving up the spectrum a little bit more is Flask, which does pitch itself as a pretty minimal framework, but when you start reading the documentation, that you realize that because it's been around for as many years as it has, and because of its rich ecosystem, you can pretty quickly bolt on some extensions that will help you build out a fairly robust application. But it starts off minimal and grows bigger. Our fourth framework here is a framework called Pyramid, and Pyramid puts itself on the full end of the feature set. It tries to have opinions about just about everything. There are some choices that you can make, like if you prefer a couple of different template rendering engines over the other, you can kind of swap them out. It's sort of configurable in that way, in that our last tool is not as much. But it does make choices about how you should structure your application so that you can use it. And then finally, Django is on the full other end of the spectrum compared to Falcon. It is a huge feature set, a laundry list of things, and you can use them or leave them. So their mindset is, if you're not going to use it, just ignore it. It's there when you need it, but that's where it is. So I wanted to, so having this in mind, of this ranking of how many features they have, I wanted to take a moment to look at how the frameworks position themselves in their documentation, their elevator pitch, to get a sense of why they are, kind of hint at that design decision I talked about, so that we can get a good idea of what each of these frameworks is about. So let's start with Falcon. Falcon's elevator pitch, and this is straight up ripped from their documentation. It's a bare metal Python web API for building very fast app backends and microservices. So clearly, the emphasis on bare metal is trying to get home this idea of, we want to go fast, and we are willing to sacrifice things to go as fast as possible. That's what they're all about, and I think it's an aptly chosen name for the project if that's their goal. So API Star is similar, and you'll see there's some themes that kind of run through a bunch of these, but the big one for this is it's specifically designed to work on Python 3. So if you don't know the Python ecosystem super well, there is still today a divide between Python 2 and Python 3. It's very quickly shifting over to Python 3, but there are lots of businesses that exist that only can operate on Python 2 because they have a lot of legacy code, and the migration is non-trivial in some ways. It's gotten a lot better, but it's still non-trivial. But the person who developed this particular framework, his name is Tom Christie. He's the author of also of some other popular tools like the Django REST framework, which is a way to bolt on some API functionality onto Django. He decided that the design of the REST framework, which he was the primary author of, was not going to be conducive enough to move to his vision of what an API framework could look like. He wanted to take advantage of some things that are only available in Python 3, for example, typing, which is optional typing, which helps the framework in some ways. And he couldn't really do that, couldn't get from A to B using Django REST framework. So he opted for a new design, and it's API Star. This is the youngest of the frameworks we're going to look at. It's super promising. I think it's really cool. It's got some cool code in it, but that's the story behind this one. Flask started out as an April Fool's joke. So if you heard me earlier, you said one of the honorable mentions I said was bottle. So there was a trend at the time when Flask came out to be talking about micro frameworks that you could fit your entire web application in a single file. And Flask did exactly that. It bolted together a couple of popular libraries, namely one called WorkZug, and the other is Jinja 2 templates. And it just fit them together in a way that you could do exactly this. You could make your whole application in a single file. I don't know why the author thought it was a joke, but that's when he put it out there, and it got traction in ways that were unexpected. Shows the power of good marketing, I suppose. But out of that, built came something pretty cool. That's very heavily used. I would say Flask is perhaps the second most popular Python framework, only behind Django. So the pyramid elevator pitch, when I was looking at this, is the down-to-earth portion of this. And the way I thought about that is it really tries to fit in this Goldilocks zone. It does have examples in its code of if you wanted to make pyramid fit into a single file, if that's really important to you for some reason, you can do it. But if you want to build some much larger application and have a lot of structure around your project, you can do that too. And as I mentioned earlier, it has some configurability into what you're going to use for different pieces of it. And a lot of that configurability exists because it's trying to give you some decisions, but give you hook points at which you can say, I actually want to swap out and use this component. So it's pretty rich in that regard. And finally, Django's elevator pitch. I emphasized high level here because Django is really big on putting everything that you can think a web application might need into a single framework. It has loads of stuff. It would take you a long time to learn it all. I think it's well worth learning it all. It's my personal opinion, but it is full of things. And it can be a little intimidating, frankly, if you've never used web frameworks before and you come to Django and you start a new project, which I'll show you a little bit of what a project structure is like. There's a lot of code that's there and you're like, what's going on? But with that power comes a lot of abilities. So let's, I think we're at a point that hopefully you have a loose idea of what each of these 5 frameworks is about. So the next logical thing to do, in my mind as a nerd and a coder, is to look at some code. So let's flip over to each of these frameworks. The scenario for this that I'm trying to show, I can't in a talk period of time go into any level of depth on all of these frameworks. Each one of them, each framework could be multiple talks in and of itself if we were to really explore the code. What I want to show in this is give you a picture of what this code looks like so you can see if it fits your coding style. You might immediately gravitate towards, oh, that is the coolest thing ever, or, oh Lord, get me out of here. Either reaction is equally valid and can be good. But the scenario that I want to show off is basically the hello world of HTML and JSON. Both of them are one's going to print out hello world to the page, which is super boring, but useful to see. The other is also going to print out or give out a data structure in JSON format of literally a key hello and the value is world, so modified hello world. So let's start with Falcon, because I said it had a pretty minimal set. And by the way, all of this code will be published on the Python Frederick repository, and I'll put links out and share those so that they're available for you to peruse at your own interest. So if we look in here, I'm using pipenv to get the project set up, and I've already done that in advance, so we're not downloading packages. But if we explore the actual application itself, this is what Falcon looks like. Falcon pitches itself as an API framework, and it is keen on the REST pattern. I listened to a recent Talk Python to Me episode where the Falcon team showed up and they were talking about how REST was important for the structure of their application, which is why they use the name of resource for the thing that you're bolting into the URLs that you care about. It's pretty explicit in what it gives you, and this is I think this is this is it, top to bottom. So what we have here is 2 different resource classes. You define an onGet method as the hook to make a get HTTP request. Likewise, if you want to do a post or handle post requests, you would do onPost, onPut, onDelete, so on and so forth. And The interesting part about Falcon that I find is that the request and the response are passed into you. They're big on dependency injection here. So rather than some other frameworks that you'll see will make you build an HTTP response object and have that as your return on your function, Falcon already gives them to you. So they've already done the building, and what you're doing here is you're adding the information you care about to the response object to send it back out. And likewise, if you cared about request stuff, you'd start pulling that off of the request. And then at the bottom here, you invoke an API instance, and you actually wire it up to some endpoints. So the endpoints that we'll have in all of these examples are /HTML and /JSON. All right, so to run this, you also get a sense of how much tooling each of these frameworks provides. I made a little makefile that just has the command that we'll need to run this stuff. And what you might notice about Falcon, if you knew the Python ecosystem, was that's a production level server right there, G-Unicorn. So their level of tooling support is actually super minimal. They just expect you to use the real thing. We're not going to give you a little development server. No, just the real stuff's good enough. That has pluses and minuses. So we're going to run make here and get Falcon going. And then let's jump out of the presentation. And of course, the new tab is on a different screen. There we go. So what was that? Localhost 8,000? No, that's the presentation. Ha. I think it was 8080. So this is going to be terribly unexciting, but hello world. There is no templates, there's no formal structure with that. It is just the raw bytes of hello world. So there's not a lot going on there. And then if we also do the JSON endpoint, hello world. I think for the rest of these, you guys can trust me when all of these examples work, it's going to be the same demonstration. So I think what I'll do for the rest is I'll show you all the code, and then maybe I'll fire it up just so that you can see the command and a little bit of the tooling that each of the frameworks uses, but we'll skip the browser part for the rest, if that's okay with all of you. So that's Falcon in a brief nutshell. Now let's look at API Star. And to build these, I tried to do the minimal thing that the documentation for each framework would tell you to do. So Falcon had no kind of generator to do it, but as you can see, it was not a lot of lines to make that much code work. API Star actually comes with a generator. So you install API Star, and then you can say API it gives you a new command that you can use called API Star, and you can say API Star new, and it will dump out a bunch of code for you that includes the test configuration and all that kind of stuff that you need to actually get going. Once I did that, I then modified this. So cool part about API Star is that by default, everything just looks like a function. It's functions all the way down. So it's smart enough to default to serialize to JSON. There's nothing magical about this name. It's actually probably badly named considering there's a JSON module in Python, but it was an easy name for our demonstration purposes. So similar kind of configuration, but they're doing the configuration here in a list rather than doing an add route method on the Falcon version. And so you're building your set of routes, and then you're invoking the app, and at the bottom of this, it invokes a main function. Okay? So I lied a little bit, I guess, because there is something cool that I want to show about API Star while we're here. But this is the whole app. Is there any questions about this little bit so far that you guys might have? Something unusual? No? Okay. One What you don't see here, which is probably a shame on me, is actually the type benefit. So I told you that API Star's big thing is that they wanted to use Python 3 types. The reason that they're using types is they do some really clever things with dependency injection. So if you, for instance, need to get access to the request, you put the request on there as the first parameter. It doesn't really matter the order, and you put the type information on there, and the framework figures out, oh, you wanted the request, we'll put it in there. But say you only want a certain parameter of the request, and you don't care about whatever is in the rest of the request. You can also say, I just want this parameter, and I want to be an integer by the time it gets to me. You can do that as well. So you can make your functions really small scope for what they're trying to solve, and what it does is it also has the nice side benefit of making these things much easier to test, because you test the smallest function you can, and the framework figures out how did you actually want all those pieces. So a whole dependency injection mechanism is built in. And dependency injection is just a fancy name for saying we're going to put the parameters in for you. We're going to figure it out. So let's jump out of here. API Star as a developer tool also includes this built-in web server, API Star Run, and that's useful. We'll jump back over here. This should still be, yep, because it's on the same port. I stopped the other one. But what I wanted to show here is that something cool about it is because of all of the type hints that you can add, it will actually build out your documentation for you. So that's a really useful thing. And there are certainly other tools that can build out documentation. That's a common thing, but it does it in pretty smart ways by using that type stuff. So for example, if I had some kind of string that I wanted in my function, this website would actually give me a way to interact and type in the string and get the response back. And so if I wanted to say hello username rather than hello world, and then I can put in my username here, it would actually say hello Matt, or whatever value I inserted. So it's pretty cool as a way to be able to play with an API and explore its features. That comes along for the ride. And there's also static assets can be easily blended in here very quickly, which you saw in the sample code. But that was all made by the default generators that hooks this up for you automatically. Questions about API Star? Is this overwhelming? Am I going too fast? Okay. Because I certainly don't want to do that.
Is it generating all of that as dynamic HTML content, or is it generating it statically and then serving it?
I think it's a combination. I think it's dynamic in the sense of the endpoints are figured out and displayed. Some of it is certainly static, so it's just using a template and then filling that in with the actual endpoint information. It generates like schema files. It's actually really, if you're interested in Python code, I found it to be some of the most interesting Python code I've seen recently. So it's a good repository to just go read and see like, oh, this is what Python 3 code can look like. It's pretty cool. All right, let's take a look at Flask. Flask, as I said in the presentation, pitches itself for its brevity, and it's pretty brief, which is nice and powerful. So this is definitely one of those micro frameworks in that you could put all your stuff in a single file if you wanted to, if you had really simple needs for some project that you're building. Flask could be a good tool to reach for. It uses, so the first two that we saw built routes kind of separately. Flask's model is you attach the route using a decorator. You attach the route to the function that you want that thing to map to.
Why one over the other? Why decorators versus defining the routes separately?
That's a great question. I think it's a preference thing, mostly, because both obviously can work. You might run into, so if you have a single file instance like this, it's pretty easy because you have your app at the top and app.route comes all the way through. As your project gets bigger, if you have like a global app instance that you then need to import in wherever you put your endpoints, there are some gotchas around possibly dealing with circular endpoints, circular errors, import errors, that's what I'm trying to say, excuse me, that you might run into. It's one possibility, and it's not super common, but if you're not careful, it can happen. And then when you get to that point, if you're not experienced with circular import errors, it might be really confusing because it's not circular import errors. They never present themselves well. It doesn't say I'm a circular import error. It just says like I can't load, which can get confusing. So I'm not saying that. Obviously, there are plenty of apps that are structured well with Flask, but I think that's one thing that could happen. So by having them be very separate steps and things that then you wire together as an explicit step, there are less of those problems, I think. So Flask is pretty reasonable in its Hello World version. And then we're going to get into a couple of the bigger ones. To make this, I followed the Pyramid documentation to make this, and Pyramid used to have its own built-in generator tool called, I think it's pcreate or something like that. That might be wrong on that now, but so don't take that as gospel. But they moved to a popular template generator tool called Cookie Cutter that the Python community has sort of gravitated towards, as if you need to generate some code using some sort of templates and mixing stuff together, Cookie Cutter is a really popular option. So what the documentation says to do is install Cookie Cutter, and then you install one of their templates sets from using this Cookie Cutter tool. So I built out a version of a Python, or of a Pyramid site that has the necessary setup for Pyramid, but it also comes configured with Jinja 2 templates for your template engine, and as well as SQL Alchemy as a database tool. So all of that is there. So all that's to say, that's why all this stuff is here. I didn't make all that stuff by hand, and you would not be expected to either. So I think. And this is where we started running into like, well, what is all this? Where do I start? I will say, Pyramid, one thing I love about Pyramid is they have excellent documentation. They have reference documentation, which is kind of a given for a lot of projects, but they also have really great narrative documentation. So if you want to start something and you want to see how it all flows together, and you want to build something bigger, which is what a tool like this is geared towards, reading the Pyramid narrative documentation is a good tool to step through and slowly see all of these pieces. The same is true for Django, which we'll get to in a minute, but I just didn't want to leave that there and like your takeaway be, oh, this is too much code. I can't possibly make this framework work, because you start to see some of the decisions that have been made for you in this structure, and down the road, those decisions become useful. But at first blush, if you're first starting out, it just seems like too much. So we're going to look, I think we're going to start with the routes file. And the routes file is a similar pattern that we've seen with other tools at this point of we're declaring what routes we need. The difference here is that the route itself is named instead of being a reference to the direct function that we've seen. And so there's home came from the template generator that I used. So I added an index and a JSON for the two endpoints that we could demo if we wanted to. So those exist over in the views directory, and I just dumped them in the default file for now. So that first one is a bunch of stuff that came from the template, and you can start to see, I'll stop jumping around. You can start to see how it integrates with SQL Alchemy by using the database session to query my model, it's giving you an example of the way that you can use this if you want to use a SQL, relational database to build your website, and just give you a sense of how to do that. For the demonstration stuff down here, here's where you can see they use a decorator called viewConfig, and this is where I gave the route its specific name. So it separates the function from the name for a couple of reasons, so that you can use them in templates unambiguously. The name should be something kind of canonical that will stick around, that even if you decide a different function name is appropriate, you never have to worry about that, because everything that points at it is going to use this one layer of indirection to reference the proper thing. So I gave it a route name and in both of these cases. And the other thing to note is in the hello world example, I was actually a little lazy. There's probably, in all the other examples I've shown, hello world is put right into the response body, and that's all you get is the characters. I didn't do that here. I just took the default template that they give you, the index. So Jinja2 is an HTML template, and I just shoved in some data into it, and I went over to the template and made a little modification so that if you were to run this one, it actually shows up, but if you were to view the source on it, it doesn't just say hello world, it actually has the HTML tags and the head tags, body tags, and hello world is dumped into the body. But that was more of a laziness thing. I'm sure Pyramid could actually just dump the raw body if you needed it to. But Pyramid's got a lot more going for it, but this is just so you can see a little bit of what the framework looks like. Any questions about Pyramid? Cool. And then let's hop over to Django. So again, Django has tooling for making a project, and it will generate the files that you need with all the necessary basic settings to get a web application up and running on a development web server so that you can start playing around with it. And then you build out your apps. Their structure is, they call things project, and everything exists underneath it is apps. So it's a collection of apps. So I just used a really bad name of app to be where our stuff is. And then over here, the other one called it routes in Pyramid. This is calling it URLs, and it's using some regular expressions in the actual URL matching, and then connects the specific functions that you want to use get wired up here. So if we were to jump over to the views file, we've got our HTTP response and our JSON response that both show up the same way. So all five of these demonstrations are roughly functionally the same, and how they get there in some cases is pretty similar, but they all have their own method. And the supporting stuff around it, again, is just when you need it, it will be there. For example, if we were to look at this project and go into the settings file, this file is 121 lines already, and it's all configuration settings of stuff. It just goes on and on and on. But there's a lot of useful things in there if you learn about them. So that's the code that we're going to do today. Any questions about the code?
So actually, with Pyramid,
Mm-hmm.
and to an extent with Django too, but I know how it works with Django. The renderers that are referenced in your method declarations, are those pre-canned, and you can bolt on new ones as needed if you need to change the way that responses are created?
I believe the answer is yes. So again, this partly comes down to settings configuration. So the way the renderer worked, it was a string. And if you notice at the end of the template one, it had a .jinja2 extension. That's the hint to Pyramid to go use the Jinja2 renderer. And then the JSON endpoint used just a JSON thing. If you used Mako, which is another popular template engine, it would look for a .mak, and so it tries to infer what the proper renderer is based on what you put in that string. I would presume that it will just bomb out if you don't put in the right, like if you type Nako instead of whatever. I don't know that for certain. It's been a while since I've actually played with Pyramid in earnest, but I think that's the method. Other questions? Yeah.
Is the operating system a factor in this?
I don't think so. I can't make guarantees, but I think that as far as I know, the frameworks we've looked at work on Linux for sure, and Mac for sure. I'm using Mac here today, and they all ran. And the one that I'm less certain on is Windows. I know Django runs on Windows. I'm pretty sure, fairly confident the other ones do too, but it's all up in the documentation.
I've posted Django on Windows. The problem generally isn't the framework, it's the web hosting. Because Python is so dependent on sockets generally, and
Oh, okay.
Windows and sockets
Don't play nicely.
don't know what they're doing. So you can do it, you can make it work, but it's usually some weird IIS workaround and through a poorly maintained package or something.
Yeah.
Or you're hosting it in Apache, which Apache on Windows then comes with its own special package. So, like, yes, you can do it. No, I wouldn't recommend it, but it's not because of the framework.
And I've also seen, so people and I've done Windows development at previous jobs as well, where you're working on some sort of web target and you use a tool like Vagrant to have a virtual machine on your box that you interact with, and it's running the web server, but you're doing all your development in whatever your IDE of choice is or editor, and that it just happens kind of transparently. That's what I mostly see with Windows, although the new Microsoft, they've gotten a lot better. They're really coming a long way with their bash support, and a lot of their subsystem support for making these tools integrate better is vastly improving. So props to them. All right, let's get back into presentation. So let's talk about features. This is going to look at big categories of features that most of these frameworks want to use or need to use, and their level of support. The first and most obvious for frameworks, I think, in my opinion, is templates. How are you going to get HTML to the user if you're doing server-side rendering? And then if we consider all of the frameworks that were looked at, Falcon actually includes 0 template rendering support. So if you want to do Jinja 2 with Falcon, you got to roll your own. But again, that's not really their model. Their model is we want to be an API framework. So we'll happily do JSON all day long. But if you want us to do templates, that's going to be a different thing. You're going against the grain. API Star does, as we saw with the docs. I don't know if it was a motivation because they needed to generate docs, but they did build an integrated template rendering that by default uses Jinja 2 templates. By the way, if you're not familiar with the Python ecosystem, Jinja 2 is by far, in my opinion, the most heavily used template engine. There are others that I'll mention, but I think it's just so common because it's so easy. And that's Jinja, like ninja with a J, in case you're wanting to look it up later. So API Star, Flask, Pyramid, Django, they all include rendering methods. Some of the method names are even the same. They say render template. We saw with Pyramid, it was actually rolled into the view config decorator where you provided a renderer option. In Django, there's a render method. So we saw an HTTP response returned directly, but if you wanted to render a template, there's a function that you import called render that you pass it a template name and a dictionary of context, and it calls the proper template renderer. I will say that Django actually uses their own template language, that it's not Jinja 2, but that's Django's way. everything is in Django is kind of Django's way. So form handling is another common thing that you might want to do. If you're building a website and you want to interact with people, they usually have to put data in somehow. And if you're going to do validation on that data to make sure that if you are asking for their year of birth and they type in the words 1956, that you say, sorry, please use a number or something crazy like that. Form handling is something that's useful. Again, Falcon, nope, not going to be there. From what I could see, API Star does not have built-in form handling of any kind. It could just be the newness of the framework. I think that could change in the near future. Flask starts to rely on its extension ecosystem for this. So they use a tool called WT Forms, What the Forms, which I think is cleverly named, to do all of their validation for forms. And Pyramid, what did I see for Pyramid? I'm trying to remember I think there was a form, it was called Deform, which was actually more about generating on the templates themselves. So I didn't know how all that worked, but that was the library that I encountered. And finally, Django has a whole forms system that's got a lot of validations as well. Database connectivity, Falcon, again, nothing. That's just their kind of mode is, and they say this they have an FAQ at the bottom, and it says, the first question on it is, why don't you have batteries included? And I think the answer is something like, that's not our goal. We're trying to be small and tight, and we're basically being a really low level that's right above the protocol level, but not full-fledged beyond that. So sorry, no database stuff there. You have to roll your own. API Star, interestingly, actually integrates with both Django's ORM, which is kind of a difficult beast to extract, and SQL Alchemy, the other popular SQL library in the ecosystem. I think that because, again, Tom Christie came from this Django REST framework side, he wants to have an integration path for people that are using Django who want to use API on the Star in the future to be able to go that way. So effort has been put in there to make that possible. Flask has a very popular SQL Alchemy extension. Again, it goes out to its extension ecosystem. Pyramid actually has two popular options. So Pyramid has a heritage of coming from the Zope project. Not directly, indirectly, the developer came from that background. So Zope is like a whole different, it's like a all of these frameworks. It was probably the first popular Python web framework. And then there was a second wave of them. So Zope has some difficulty, I think, around its configurability, and it's just not the most friendly in its user ergonomics as a developer. But there is a really cool technology that came out of it called the Zope database, ZODB, which is an object database rather than a SQL database. So that's a powerful tool that you can use. And Pyramid works with SQL Alchemy as well. And then Django has its own object relational mapper. Again, the theme, Django goes its own way. Not that it's a bad way, it just goes its own way. All right, this is kind of an interesting one. Security is something that you don't necessarily think about, but is critical. And so from what I saw from these frameworks, I was actually a little bit surprised. So again, Falcon, not surprised, doesn't have any integration with security kind of features. But I didn't see any in API Star, like not even cross-site request forgery or cross-site scripting protections of any kind. I didn't encounter any of that. And the same was also true of Flask. I didn't encounter that either. Now, I'm not saying that the extension ecosystem doesn't have them, but in my exploration of it, I didn't find them, which I thought was a little bit surprising. Pyramid does include a whole permissions system. It's a pretty extensive topic. They have stuff for the CSRF and XSS and the ones that you'll find on what's the top 10? OWASP. Yeah, thank you. Those things, those kind of protections are in there. And then Django has plenty of this as well. So security is a big topic in Django. There are all sorts of things you can do to lock down your site. So these are the four that I covered, just to give you a flavor of how much are these frameworks doing. Some you can see are doing basically nothing at all except making it possible to get stuff over the internet. And then some are just doing a ton. I left out a whole lot of different topics that we could consider. If you work with SQL databases and you need to migrate tables to include new columns or remove columns or make changes to columns, database migration is a popular pattern to apply to have your code actually make the changes to your database so that you can be in a consistent state, and you can have developer databases that match up with production databases as close as possible, at least at the schema level. But that was a topic that I left undone. Caching, how to deal with caching, email, internationalization, logging, background work. All of these topics are things that I think web frameworks can do. Not many of them do them. Now here's my Django bias coming out. I actually stole the topic list from the Django documentation, so you get a sense of what Django is doing. It actually has answers for all of those things. But again, you don't have to explore them right away. All right, so let's start to close this up. But before we do that, how can we end without like just doing a bad comparison of numbers and being really unfair and not considering all the facts? Let's look at some performance benchmarks, because why not? Let's see here. Where did you go?
You haven't mentioned cost. Is it?
Cost?
Yeah, for a non-factor.
It is all of these are open source software, so they're all free for you to use. And they all have licenses which basically say, if it's broken, you get to keep the pieces. Don't come calling to us. I lost the actual tab that had the framework. So what I'm going to show you, if I can find it, there we go, is a website called Tech Empower. And what they do is they aggregate benchmarks and they try and give some sense of the performance of these frameworks, but they're biased. The quality of the benchmarks is only as good as the person writing the benchmark code. So, take this with a grain of salt. That the comparison I'm showing is interesting at some level, but I think it's interesting to show you kind of the raw performance of some of the frameworks in terms of what is the level of overhead that you can expect this framework to add to your stuff. And it doesn't matter how good these frameworks are. If you're writing SQL code, for example, and you have a table that's missing a database index and you're doing a full table scan on billions of rows, it doesn't matter how fast these frameworks are, your database is going to be a problem. So just my disclaimer, but it's still kind of fun to look at numbers. All right, so here we go. And I brought in more than just the frameworks we were talking about because I wanted to compare them to a couple of other languages. So I brought in PHP and Ruby and just picked a couple of them. Sorry, I didn't know which were the fastest PHP frameworks, so maybe this is not a fair comparison. But I did bring in at least ones that I knew were popular. But what we see is a few different kinds of tests that show different things. And this is a JSON serialization test, so it's kind of like, I don't know, I haven't looked at the actual benchmark code, but I presume it's something similar to the Hello World example of how fast can you take in-memory dictionary-like data and put it into a JSON structure that can be read on the other side, and what kind of throughput can you get. And maybe surprising, Falcon's actually not the fastest in this case. You'd think, like, after all that talk about like we're not doing anything, API Start still comes out in the lead here. And I think I'm wondering, I don't know for sure, but it might be because of the way the dependency injection framework like kind of builds the most optimal code path, getting down to that core of only do the stuff you really need. So if you only need one parameter, we're not going to do a ton of extra parsing on all this other, on the body or whatever other stuff might happen in the side. We're just going to focus on this little bit. So that's all I can figure that would put API star out on top. But if we go down the numbers here, the Python frameworks actually fare pretty well. We get down to Sinatra. This is a Ruby framework, but then we have more Python frameworks, and then Sinatra again, and then we get down to the bottom of the list, and then we have some other contenders with Rails picking up at, wow, 461 requests. That's, I don't know, yeah. Anyway, I'll keep my mouth shut. So this is just fun to see, in my opinion. Like I don't know what you can take away from this, but the other kinds of tests kind of tell different stories too. So here's a more realistic test that gets into, we're now going to query a database and then give you a response and what's the throughput now. So now we're no longer talking 461,000 requests in whatever time frame this is. It's something a lot more realistic. And then the comparison, because now you're bringing the database into the equation, is these things are a lot more on par with each other. So it's kind of a mixed bag again of what happens. Again, Rails at the bottom. So interesting stuff. And then you might notice actually API star is not in here. Yeah. So the way these benchmarks work out is not every framework has to complete every test to do this. And I think this comes back to API star is less than a year old, and just they haven't written all the tests yet. So we don't know. I'd love to see how it compares on these, but it's not there yet. Maybe I'll go write the PR. And this is multiple database queries, and I don't even know what these two tests mean of fortunes and data updates. But I don't know. It's been fun to look at. I think we can say that out of this, Python is certainly competitive as a language. And if you're looking for speed of just a framework, of the overhead that the framework puts into whatever web task you're trying to do, if I were to zoom this out and look at all the languages that are in here, the languages that actually perform best are C++ and Java, but then you'd have to work in C++ and Java for web frameworks. So not for me anymore, but that might be your thing. All right. So there's a little bit of performance stuff. Any questions about performance? Did anybody want to see anything else that I wasn't showing?
I don't have any questions. Unfortunately, I do have to go.
Okay. No problem. Thanks for coming. So I'm going to wrap up. So just a reminder of what our key question was is what is the right framework for your next web project? And the answer, like any good computer scientist answer, is it depends. Depends on what you're trying to build. I think there are good choices out there. I think any of these frameworks is a great fit for some project. It's a matter of finding which one works well for you. So that's what I have for us tonight. Are there any final questions before we close out? Cool. Thank you for your time.